we're going to do a 3D relief cut in a beautiful piece of laminated oaken pine. So we'll jump over to the CNC router and I'll show you how to put it into Mach3 and set Mach3 up and start the machine cutting. So this is the setup that I have. This is a CNC router and I run it with a Windows 7 laptop, and I've got a larger screen up there so you can see what's going on in Mach3. I would encourage you to go back. About a month ago I put a video up that I described everything about this CNC router and what you probably should be looking at in a good unit, because there's a lot of CNC routers out there on the market that, quite frankly, you'd probably be throwing your money away. So go and have, if you're interested in buying a router, go back and have a look at that video where I show you what to look for. Okay, so I'm going to load the program, the Rough-in Cut program, the G-code, into the laptop, but I'm going to put the camera up on the big screen so you can see what's going on. Okay, so this is Mach3, and when you start Mach3 up, this is the screen, the opening screen, the run-in screen window, and you will have this reset flash in. While this is flashing, nothing will go through to the CNC router, so you cannot operate it. It's a safety measure. As you can see here, emergency mode active. So what we're going to do now is we're going to load up the Rough-in toolpath, which I carried out in Vectric Aspire, and you'll find that entire video on my second channel. So we will press reset, come up here to this top left hand corner, press file and press load G-code, and here's the G-code that I require. Just double click it and it goes into Mach3. Now at the moment Mach3 has just put this program, this G-code program, which is represented here, in the last 00 point that I had the machine running, or I made in Mach3 for the machine. So we're going to turn the machine on now and reposition this, or make the new 00 point, or what is known as the work offset. I will explain about work offset and machine home next. This is the spindle. This is a 2.2 kilowatt spindle. So this is the router itself. You have a chuck, and this is where the cutters go. So this router head will move up and down in the Z axis. Then this carriage will move across the machine back and forth in the X direction, and of course the gantry itself will move up and down the machine in the Y axis. So the position that this router head is in at the moment, which is all the way up, all the way over and all the way forward, this is called the machine home. Okay, so this is where the router lives then, and it's the easiest place for you to change a tool. It's very comfortable, easy here to change a tool. So we have to now tell the computer program where the work is. Okay, now in the program, when I wrote the program in Vectric Aspire, I wrote the program with the 00 point, alright, so it's the X, Y, 0 coordinate, of the program, which is the start of the program, in the middle of the material. I'm going to mark that with an X. So now what we're going to do is we're going to move the head or the router over, and I've got quite a sharp tool here, over to the X position and register that work position, or what is commonly known as the work offset. In other words, it's quite simply, this is the home position, and that piece of work, the start of that work is offset from the home position. Okay, so this is commonly known as the work offset, where the start of that program is. So we're going to set that up now. But first I'll just show you in Mach 3 on the screen there, the machine home position, or the machine coordinate. Okay, so we have the Mach 3 screen here. Now this is the G code itself, and as the program is running, this will scroll through fairly quickly. Now this section here, this is called the DROs. Okay, so, or digital readouts. This gives you the coordinates of exactly where the tool is, and we're going to alter this now. At the moment, see this this button here, it's highlighted red. That's highlighted to show that this reading is the machine coordinate. Actually, in fact, if I move that, it'll tell you. Machine coordinate. If you press that button, so this now is showing you, well, where the computer thinks the start of the work is, or the work offset is, but we haven't set it yet. This button here, this is soft limits, it's green. Always have the soft limits on. So then your router head will not, or the router tool will not go outside the envelope of where it's supposed to machine. So we will set this now correctly. I'll move the router tool over to the work offset position, and we'll set the new work offset. Okay, now there are several different ways in which you can move this head around, or move the machine around. Now I use a pendant. Okay, this is a radio controlled pendant where I can operate the machine just by selecting a particular axis and moving it thus. But you can use the arrow keys and the page up and down on your computer board, or on your computer keyboard, or your laptop keyboard, which is simply this. So that's the right arrow, that's the up arrow, forward arrow, and page down. Okay, so you can operate a CNC router by using the arrow keys and the page up, page down on your keyboard. Simply like this. If you notice that this motion actually is called jogging. When you move the router head around the machine to find a particular location using either a pendant or the keys on your computer, this operation is called jogging. I don't actually know where that comes from, but that's the common terminology for it. Okay, so I'm going to use my pendant now. So I'm going to select a low setting, and even lower than that. Very precise. X. So what we're doing, I'll zoom you in a bit. So what we are doing, we are finding the precise location of the center of this material. And we'll take it down slightly. To very close to the material. And we'll go back slightly. And then we'll take it over. That's pretty well the center of the material. Now I'm just going to get a little piece of paper and I'll show you what we're going to do with that. Okay, so we're going to get a little piece of paper and we're going to put underneath the tool there, and we're going to fetch the tool down very quietly, and we're going to move the piece of paper. Okay, and what we're going to do, we're going to fetch a tool down so it just traps that piece of paper. So then we know that the end of that tool is absolutely on the surface of the material. That's it. Just trapped it there. So now we can set the work offset in Mach 3, and I'll take you up to the screen for that. So what you do to set the new 0, 0 location is you simply go to these buttons here, just off from the arrows, and you just press. Notice it goes to 0. So it's X 0, Y 0, Z 0. I think the camera wandered a little bit there, so I think you saw what I was doing with the DROs. I'll just press the regen again. Okay, so it just regens the program, and what I was saying then was that you know, the representation diagram of the work jumps in the correct position. Here's the crosshairs that shows the 0, 0 position, and the machine home position is here in this corner. So this now is the work offset, and this is actually in technical terms called the G54. If you ever see G54 written anywhere, this is what they're talking about, where the start of the program is, or the work offset. A little bit of explanation before we go any further. The first half of this year I will be showing you quite a lot about Mach 3 because I've had a lot of people email me and message me in the comment section that they require more information about Mach 3. Mach 3 was a program that was written back in the early 2000s for originally XP. But over the years it's been upgraded all the way up to Windows 7. I believe it will operate too on Vista and also Windows 8. And possibly early versions of Windows 10 if it's a 32-bit. Okay? It's not written for a 64-bit, so it won't work with the modern Windows 10 computers. So I just buy second-hand Windows 7 computers, whether it's a laptop or you know, a mainframe computer, doesn't matter. You don't have to put any CAD or anything like that into the computer. You just download Mach 3 program from Artsoft. It is still current. A lot of people out there, you will see that, oh, it's not supported. Yes, it is. So you can go along to Artsoft and download this free of charge for the demo version, and it will give you, I think, 500 lines of code that you can use. You can use that program for free until you really want to do some work on it. Then you have to pay for the license. okay? And it is I regard Mach 3 as the best bang for the buck. It really is. The program has been used for 15 years or more. It is well sorted, and you will see a lot of people out there saying, oh, you should use this program, that program. Well, I can tell you now, if you're starting off on CNC or sort of a professional with CNC, look no further. Okay, it works with standard computers. Okay. So I will be doing some tutorials on how to use Mach 3 in relation to your CNC router and CNC mill and also CNC lathe. And if you look back through my channel, you will also see quite a few videos on Mach 3. So we will get on now, and the next job I need to do is to raise this up and change this tool to a 1/2 inch or 12.7 millimeter cutter, and which is one of these. It's a standard 1/2 inch rotor cutter. Okay, so that's what we're going to put in this chuck and use. Now this type of rotor comes with a special type of chuck. It's called a collet chuck. Now this is the chuck nut then, and inside there it's got a taper that mates up with this taper here. And of course inside the shaft in here there's a taper that coincides with this taper. So the action is that you put clip this into there, put your shank of your tool in there like so, and screw it up, and one taper goes inside the other and crushes down on this shaft. And it's a very secure way of holding a tool, and it will hold it very square, which is very important. So we're going to put this in here now and reset the Z again because we changed the tool. So you hold the shaft with one and put it up firmly. So get a piece of paper and just bring it down quietly. That's it, just grabbed it, and we can reset now the Z0 for this new tool. So before we actually start, what I do, so it allows me time, if I see anything going wrong, to actually stop, hit the panic button. Now to stop the program, you can either hit reset, you can hit stop, you can press feed hold. Any one of these three will stop the program and stop the machine running. But don't hesitate, hit this one here, or the emergency stop on your machine if it has one. So what I do is I come across to here, this minus button here, and this is the feed rate, and I bring this feed rate all the way down to 20% is fine, because that gives you time, if you see anything going wrong, to stop the machine in its tracks before it does any damage. And now, so to start the program running, just simply come up here to cycle start.